In this recording, we're going to learn how to solve linear quadratic systems. So a system that has a quadratic equation and a linear equation. And obviously you don't have a partner to do this exercise, but with yourself, I'd like you to consider what are the possible types of solutions you could have. What are the numbers of potential solutions you could have with a line and a parabola? So why don't you consider that and see if you can come up with the three possible cases and just draw out some sketches. Play the recording when you're ready. Okay, so hopefully you considered this and thought about, in any order, you could have one that was a no solution. So you'd have something like this with your parabola and the line that does not intersect with it. Okay. You've got your one solution case, so this could be your parabola and the line that just comes along and hits it at one point. Okay, so it's tangent to the line. And then a pretty typical case, I'm drawing all my parabolas downward, but it could be any which type of parabola, any type of line. The two solutions. Next, we're going to consider this system that has a quadratic and a line, and we're going to solve it by substitution. Very similar to how we solved our linear system. You've got something that's equal to y. So to find where those two equations are equal, I'm going to substitute in place of that variable y in the top equation. So we're just simply going to write out x minus 5 in substituting in place of that y. And then I'm going to write out the rest of the top equation. Now this should be something you should be comfortable with solving now. And you should know that almost all the ones we're going to do in our class are going to have rational solutions. So you're not going to need to get into the quadratic formula. You're going to be able to factor this. They're going to be nice solutions, usually integers, not even fractions, but possibly a fraction. So let's get our y by itself, assume our 0 on one side, and let's proceed to factor this. So get as far as you can with this to solve for x, and play the recording when you're ready. Okay, so hopefully you've got x squared by subtracting x. We now have negative 7x by subtracting, by adding a 5, we now have a 10. Okay, so let's use our zero product property and set each one of these factors equal to 0. Okay, keep in mind, we're not stopping here because that's not the solution to a system. A system has points as solutions. So now solve for y. Use whichever equation is easier. I like the bottom one. So that leads us to the 2 points, which are... Cool. So now we're just going to solve this by graphing. Confirm by graphing. It's easy to graph a line, you know its slope, you know its y-intercept. Any parabola, though, we're going to want to show a table of values. So grab your calculator, or if you don't have a graphing calculator, use the axis of symmetry to come up with what the middle is, and then maybe sub in some points. Play the recording when you're ready to look at this line. Okay, so if you came up with the line easily, got a y-intercept of negative 5 and a positive slope. Now I'm ready to graph the parabola. I'm going to do so by making a table of values. First I'm going to consider the axis of symmetry, negative b over 2a. So that would be negative 6 or positive 6 over 2 times 1, which is 2. So the axis of symmetry is going to be 3. I'll put 3 in the middle of my table. And you can go to your calculator, or you can just kind of write down what I've got here, because you will have access to a calculator on the test. So one thing to look at first off is, do our points 5, 0, and 2, negative 3 show up on the table? And sure enough, we've got both those points right on our table, so that's very encouraging. That means they're going to be part of this solution set on the graphs. Go ahead and plot that parabola's points. Good. So our final example, I'd like you to work this one out on your own. Approach it the same way we did it. Get as far as you can, then play the recording, check your answer, or if you need help. Okay, so hopefully you managed this one and worked this out. So if you got an answer, go ahead and play it to the end, see if you're right. if you needed help, play it as slowly as you need it. Alright, so hopefully you ended up with these solutions, and now let's proceed to go ahead and check this graphically. Make that line, make that parabola, and see that those points are the intersection points. So we're going to find the axis of symmetry for the function f of x, so we know where to put in the middle of our table. So we're going to go x equals negative b over 2a, so negative 4 over 2 times 1. So x equals negative 2. We're going to put that right in the middle of the table, and then use our calculator or our head to create function order pairs. So first of all, one thing to recognize is negative 3, 8, check. 2, 7, check. So this is already good news for us. But let's proceed to make the graph anyway. I appreciate you being patient with me. It's really difficult to make a parabola on this surface. Hopefully yours looks a lot better than mine. But do add your label. That's important anytime you have more than one function on the same graph. Thanks for watching.